Section 1.4, using the definition of the trigonometric functions. Reciprocal identities for all angle data for which both functions are defined. We always talk about like the 6 trigonometric functions, and we mentioned the reciprocal identities in the last session. So sine will be equal to 1 over cosecant. Okay, means like once you find out what is a sine, you could flip the sine, you're gonna get the cosecant. And then cosecant equal to 1 over secant. So once you find the cosine, your reciprocal of the cosine, that will be equal to the secant. Tangent and cotangent also. Tangent will be equal to 1 over cotangent. We talked about it from the last session already. Example 1. Find cosine theta given that secant equal to 5 over 3. We're gonna apply the reciprocal identities. Cosine theta will be equal to 1 over secant. Okay, so you know secant theta equal to 5 over 3. You could plug it in. Reciprocal of 5 over 3, that will be 3 over 5. Okay, I want you guys try to do this one. Okay, sine theta will be equal to 1 over cosecant. Okay, so reciprocal of this guy. You are not done yet. You need to rationalize. But before you rationalize, you could simplify the square root of 12, right? Square root of 12, I could break it down to 4 times 3. Square root of 4, that will be 2. So 2 square root 3. Okay, we're gonna plug it in. We could simplify. 2 and 2, simplify it so you only have a negative 1 over square root 3. Now, you could rationalize the denominator. So you're gonna times square root 3 over square root 3. Final answer, negative square root 3 over 3. Size of function values. Okay, we talked about this part on the session 1.3 already. Let's talk it one more time. We do have the quadrant. Okay, quadrant is going to be going from counterclockwise. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we also state that x and y in this quadrant, that will be positive and positive. So you can see greater than 0. And r is always greater than 0. Okay, quadrant 2, since the x-axis is going to be here, that will be less than 0. So x is a negative, y will be positive because y-axis is still above the 0. Okay, and then they also state like the sine and cosecant is a positive. Tangent and cotangent is also positive, right? We proved this part on the session 1.3 already. You could review it. Okay, how can you guys remember it? I usually try to memorize it with the cast, C-A-S-T. Okay, and then the C, we're gonna start in the quadrant 4. So C represented like cosine. Cosine will be positive in here. And then A represent all the trigonometric functions in the quadrant 1 will be positive. And then S, we're going to be quadrant 2. S represent the sine, okay? Sine theta will be positive in this quadrant. And then last one, T. T represent the tangent in this quadrant will be positive. Okay, C-A-S-T. Make cosine positive here, all positive quadrant 1, sine positive in the quadrant 2, and tangent will be positive on quadrant 3. Okay, now let's try to fill in this table. So quadrant 1, data in quadrant 1, all the 6 trigonometry will be positive. Okay, so I'm gonna write it down. Quadrant 1, all the trigonometric functions will be positive. And then quadrant 2. Quadrant 2, I do have a sine is positive. For cosine and tangent, in this quadrant will be negative. Okay, I will try to work on these three guys first. And then quadrant 3, only tangent will be positive. And then other than that, that will be negative. Quadrant 4, only cosine is positive. So sine and tangent, that will be negative. Now I'm going to work on the cotangent. Okay, remember the reciprocal identities. Cotangent is equal to 1 over tangent. Okay, so that will be followed by the tangent data. Positive, positive. If this is a negative, this is a negative. Positive, positive. Negative, negative. And then secant, you could copy the sign of cosine data. Okay, secant and cosine. Last one, cosecant. Cosecant, you could copy the sign of sine data. Okay, so positive, positive, negative, negative. Okay, right? I need you guys remember the cast. C-A-S-T. Okay, cosine or sine and the tangent. Once you guys remember the sine, cosine, tangent, you should be able to figure out cotangent, secant, and cosecant. Okay, example 2. Determine the size of trigonometric functions of an angle in standard position with the given measure. 87, so let's look at here. Okay, 87, we do have a 0, 90, 180, 270, and then 360. So 87, that will be stay in the quadrant 1. And then quadrant 1, all the trigonometric functions will be positive. Okay, B, 300. 300 should be, this is a 270, right? So 300 should be quadrant 4. Quadrant 4 is only cosine and secant will be positive. Other than that, it's going to be negative. Okay, so cosine, secant are positive, while sine, cosecant, tangent, and cotangent are negative. Okay, C, negative 200. Negative 200. Negative means you're gonna go from here, going clockwise, starting from the x-axis, going like this way. Okay, so think about it. If going backward, this is a 0, this is a 90, this is a 180. So 200 should be starting from here until quadrant 2 here. So quadrant 2, only sine and cosecant are positive. The rest will be negative. Example 3. Identifying the quadrant of an angle. Identify the quadrant or possible quadrants of any angle data that satisfy and given the condition. Okay, first, sine theta is going to be greater than 0. So sine theta is positive. It's only quadrant 1 and quadrant 2. All right, quadrant 1 or quadrant 2. And then the tangent has to be negative. So it has to be quadrant 2, right? Okay, I want you guys try the B. Okay, B. Cosine is negative. So negative will be quadrant 2 and quadrant 3, right? And secant, that will be the same as a cosine. So satisfy this given condition. You can have quotient 2 or quotient 3. The range of trigonometric functions. Sine and cosine, the y is always in between -1 to +1. Okay, you could look at the notation. Sine and cosine, the range talking about the y values is always in between -1 and 1. Tangent and cotangent, the range can be -infinity to +infinity. So you could think about it, it's going to be all real values for the range. And then secant and cosecant, that will be from -infinity to -1 or from 1 to the +infinity. Okay, so later on, when you guys know how to graph these functions, then you're going to remember all the domain and the range. Decide whether each statement is possible or impossible. So sine theta equal to 2.5. Okay, sine theta equal to 2.5. This is talking about the range, right? You could think about y equal to sine theta. So y equal to 2.5. Is it possible? Go back here. Sine, the range is always in between -1 and 1. 2.5 is the outside of this range. So that would be impossible. You can try to use the calculator. You could do inverse of the sine 2.5. You're going to get the error on your calculator. Okay, B, tangent theta is going to be 110.47. Okay, look at the table, and I want you guys try to do it by yourself for the B and C. Okay, check your work. Tangent theta equal to 110.47. The range for the tangent theta will be all real numbers. So this is good. It's possible. Okay, secant. Secant is from -infinity to -1 and from 1 to +infinity. So 0.6 here is going to be impossible. Example 5. Suppose that angle theta is in quadrant 2 and sine theta equal to 2/3. Find the values of the other 5 trigonometric functions. So we could choose any point on the terminal side of the angle theta. And then you know sine theta is equal to 2/3. Okay, remember that will be y/r. So that means y equal to 2 and r equal to 3. So we try to figure out what is your x. Remember the formula? X squared plus y squared equal to r squared. So plug it in. Let's see what did you guys get. So y equal to 2, r equal to 3. And then we're going to calculate it. So x squared equal to 5. So x is going to be plus minus square root of 5. So think about it. Since the data is in quadrant 2, right? Quadrant 2 for the x is going to be negative. So x is equal to negative square root of 5. Okay, so we do have this picture here. X equal to negative square root of 5, y equal to 2, and r equal to 3. Okay, cosine theta, that will be x over r. Okay, x over r. So negative square root 5 over 3. And then secant. Secant, that will be reciprocal of this guy. Okay, and then make sure you rationalize. You should get your answer negative 3 square root 5 over 5. Okay, I want you guys try to find the tangent, cosecant, and cotangent. Okay, check your word. Tangent y over x, rationalize, you should get negative 2 square root 5 over 5. Cotangent, you could reciprocal of this guy. So negative square root 5 over 2. Cosecant, that will be reciprocal of this guy. So 3 over 2. Quotient identities. For all angle data for which the denominator are not 0, the following identities hold. Sine theta over cosine theta equal to tangent theta. And then cosine theta over sine theta, that's equal to cotangent theta. Remember these two quotient identities. Pythagorean identities. For all angle data for which the function values are defined, the following identities holds. So first one, sine squared theta plus cosine squared theta equal to 1. Okay, and then I show you guys Now I show you guys these three identities. We do have the second one, tangent squared theta plus 1 equal to secant squared theta. And the 1 plus cotangent squared theta equal to cosecant squared theta. Okay, let me show you guys how to get these three identities. Okay, usually I only need to remember this identity. Okay, sine squared theta plus cosine squared theta equal to 1. Okay, what we're gonna do? We're gonna do divided by cosine squared theta for the whole equation. Okay, so sine over cosine, that will be tangent squared theta. Cosine squared theta over cosine squared theta, that will be equal to 1. 1 over cosine, that will be the secant. So secant squared theta. This is how we get the second one. Okay, how about the third one? Let's do it one more time. Okay, starting from sine squared plus cosine squared theta equal to 1. Okay, this time I'm gonna over sine squared theta for the whole equation. Okay, sine squared over sine squared, that's equal to 1. Cosine over sine, that will be cotangent. 1 over sine, that will be cosecant theta. So we're gonna get another identities. Okay, I gotta bust it up. You guys need to remember these three identities. Example 6. Find sine theta and tangent theta. Given that cosine theta equal to square root 3 over 4 and sine theta greater than 0. So we want to find sine and tangent, and they only given the cosine, and also the sine theta is greater than 0. So either the theta will be cosine 1 or cosine 2. Now let's start with this identity. So we could plug it in for the cosine in here. Okay, take square of the square root 3 over 4. So that will be 3 over 16, right? And then we're going to subtract from 1 here. Okay, we have a sine square theta equal to 13 over 16. Now I'm going to take the square root for both sides. When we take the square root for both sides, we will have the plus minus. Okay, square root of 16, which is going to be equal to 4. And then remember that the given sine theta is going to be greater than 0. So we just ignore the negative one. So sine theta equal to square root 13 over 4. Okay, now we want to find the tangent theta. So we'll be using the quotient identity. So tangent theta will be equal to sine over cosine. We found the sine theta already, and then cosine theta is going to be given. Okay, now we have a square root 13 over 4 divided by square root 3 over 4. So the 4 I could cancel out. I only left with square root 13 over 3. Now I want to rationalize, so I multiply by square root 3 over 3. Okay, so that will be square root 3 times square root 3, which is going to be equal to 3. And this is going to be square root of 39. Okay. Caution, be careful to choose the correct sign when square roots are taken. So keep in mind that we want to find the sign here. When you take the square root for both sides, you have to add the plus minus. Okay, we're going to look at like the given information to make sure you're going to keep the positive or keep the negative. Example 7. Find sine theta and cosine theta. Given that tangent theta equal to 4 over 3 and theta is in cosine 3. Okay, cosine 3 is only tangent and cotangent are positive. So you have the idea that sine and cosine will be negative numbers. Okay, tangent theta equal to 4 over 3. First, let's try to find the cosine theta. We need to find the identities that is related to the tangent and cosine. Okay, the three identities, not the first one. Second one, we do have a tangent square theta plus 1 equal to secant square theta. Okay, do you guys remember that secant and cosine, they are reciprocal of each other, right? So if we could find the secant and then we can find the reciprocal, that would be the cosine. Now we're going to plug it in. Tangent square theta, we're going to plug in 4 over 3 square here. Okay, so that will be 16 over 9 plus 1. Get the same denominator, you're going to have 9 over 9 here. So 16 plus 9 over 9, which is going to be 25 over 9. Now we want to take the square root. One more time, the theta is going to be in cosine 3. So for the secant, that will be negative. Okay, so we will take the square root of it, that will be 5 over 3. And we know cosine 3, that will be negative for secant. Now we want to find the cosine, right? So reciprocal of the secant, that will be equal to your cosine. So now you should get cosine theta equal to negative 3 over 5. Okay, double check, theta is in cosine 3, so cosine should be negative. Okay, now we want to find the sine theta. Okay, so we could use the identity again. So that will be 1 minus cosine squared theta. Plug it in. you should get 1 minus 9 over 25. Get the same denominator, so 25 over 25, which is 16 over 25. Now I'm gonna take the square root for both sides. One more time, theta is in quadrant 3, so it's supposed to be negative for the side. So that will be negative 4 over 5. Actually, for this example, that's another way to do it. We already know tangent theta equal to 4 over 3. And also, the theta will be in the quadrant 3. So we could sketch the theta here. Okay? And then we have the coordinate, negative 3 and negative 4. We just need to find out the R. And then using the definition of the sine theta and cosine theta, x, y, and r, you should get the same answer. Okay, so that's a two method to working on this example. That's it.